Solving linear equations. The basic method of solving linear equations is to perform algebraic operations on the system that do not alter the solution set and produces a succession of increasing simpler systems until a point where it can be ascertained if the system is consistent or has a solution. The algebraic operations are: 1. Multiply an equation through by a non-zero constant. 2. Interchange two equations. 3. Add a constant times one equation to another. You are required to know how to solve a set of linear equations using elementary row operations. The next video will demonstrate how to solve a linear equation using elementary row operations. Solving a linear system using elementary row operations. When you're solving a system of linear equations using elementary row operations, it's advisable that you first number your linear equations. For instance, in this instance, we're going to have this will be our equation 1, this will be our equation 2, this will be our equation 3. When you're using elementary row operations, the principle is you are trying to eliminate in equation 2, you are trying to eliminate this. You're trying to eliminate the variables of x in equation 2 and 3, and in equation 3 you are also trying to eliminate the variables of y. So how you do that, you're going to work from coming from equation 1 going to equation 3. That's why it's called a forward approach. Then after you've eliminated these variables and this variable, you're going to work backwards. But at the moment, we are first trying to eliminate in equation 2, we are going to eliminate 2x. We want to find an equation where we want to find a situation where if we add the second equation to the first equation, we eliminate the variables of x. We look into the first equation and say, what is the constant that if I multiply that constant with equation 1, I will be able to add equation 2 to equation 1 and eliminate x. So you need this to be minus 2x, because you know that minus 2x plus minus 2x is equals to 0. And another fundamental principle that we need to learn from the start is that if you add equation 1 to equation 2, adding equation 2 plus equation 1, you are going to get equation 2, a new equation 2. This is now a new equation 2. If you add equation 1 to equation 2, we are going to get a new equation 1. In this instance, you want a situation, you want to multiply equation 1 by minus 2. You multiply both sides of your equation by minus 2. So minus 2, you're going to get 2 times x, you get minus 2x. Minus 2 times y equals minus 2y. Minus 2 times 2z minus 4z is equals to minus 18. Now, you have your equation 2, which is equals to 2x plus 4y minus 3z is equals to 1. Now you want to add it to this equation. This is your equation 2. You want to add it to this equation, which is minus 2x minus 2y minus 4z is equals to minus 18. So you are adding these two equations so that you can get your new equation 2. Therefore, minus 2x plus 2x minus 2x is equals to 0, plus 4 minus 2y is equals to 2y, plus 2y minus 3z minus 4z is equals to minus 7z, which is equals to 1 minus 18 minus 17. So this now becomes your new equation 2. So you would want to rewrite your equation. So you're going to rewrite your equations as your first equation was x plus y plus 2z is equals to 9. That was that's our first equation. Now our new equation, the one that we have worked out, our new equation, which is this one, minus 2y plus minus 7z is equals to 17. You put now your new equation, which is 2y minus 7z is equals to minus 17. This is our new equation 2. Then our equation 3, which is 3x plus 6y minus 5z is equals to 0. This is our equation 3. So now we shift our focus. Now we shift it to equation 3. We want to eliminate 3x. So the constant that we have to multiply the first equation, so that if we add the third equation to the first equation, we eliminate x, is minus 3. So minus 3 times minus 3 times x equals to minus 3x minus 3 times y equals minus 3y minus 3 times 2z is equals to minus 6z minus 3 times 9 is equals to minus 27. This you want to add the third equation, which is this one, plus 6y minus 5z is equals to 0. You want to add the third equation to this equation, the first equation, which would multiply by minus 3. This is equals to 0. Minus 6 minus 3y, 6 minus 3y is equals to 3y minus 5 minus 6 minus 11z is equals to 0 minus 27 equals to minus 27. So this becomes your new equation 3. So now you rewrite your equation, which is x plus y plus 2z is equals to 9. 2y minus 7z is equals to minus 17. This is your second equation. This is your first equation. Then your third equation, which is this one, this is 3y minus 11z is equals to minus 27. So you've successfully achieved your first objective, which was intended at eliminating the x's. Now you want to eliminate the y. So the y in the third equation. So you want to eliminate this y in the third equation. So you look at equation 3 and compare to equation 2. You look at equation 2 and say, I want to change my equation, this variable into constant, into 3. What number can I multiply this number, this 2, so that I can get 3, minus 3 in fact, so that if you have minus 3, 3 minus 3 is equals to 0, so that you eliminate this y. So on this equation, you're going to multiply equation 2 by minus 3 over 2, because you know that 2 cancels this 2 and you get minus 3y. So you multiply this whole equation by minus 3. So you have minus 3 over 2 times 2. We have minus 3 over 2 times minus 7z which is equals to, also multiply the other side, 17 times minus 3 over 2. Therefore you get minus 3y plus, because minus times minus is equals to plus, 3 times 7, 21 over 2z is equals to 17 times 3 over 2. 17 times 3 over 2 is equals to 51. Minus times minus is equals to positive. So you get 51 over 2. Therefore, if you're going to, you take your third equation 3 and say 3y minus 11z is equals to minus 27. Add it, this is equation 3, you're adding equation 3 to equation 2, which you'd multiply by minus 3 over 2. Then this is minus 3y plus 21 over 2z is equals to 51 over 2. If you add this equation, you are going to get 0 here, minus 11 plus 21 over 2. Here you have to be careful, because 11, you have to change your 11 into a multiple of 2. You have to change this 11 into a multiple of 2. 11 as a multiple of 2, it's equals to 22 over 2. Then you can subtract it, minus 22 over 2 plus 21 over 2 is equals to minus half z, equals to the same thing with your 27. You have to convert it into a multiple of 2. 7 as a multiple, 27 as a multiple of 2 is equals to minus 54 over 2. So minus 54 over 2 plus 51 over 2, you get minus 3 over 2. Therefore, minus half z is equals to minus 3 over 2. Then you multiply both sides by minus 2, because you only want to be left with z. Multiply both sides by minus 2. Therefore, z is equals to, this will cancel, and the negatives will cancel, become a positive. Z is equals to 3. This will cancel, the negatives will cancel. So z is equals to 3. So rewriting your equation, when you now rewrite your equation, you're going to have x plus y plus 2z is equals to 9. This is your first equation. Your second equation was 2y minus 7z is equals to minus 17. This is your second equation. Then your third equation, remember we said we added this third equation, we added the third equation to the second equation to get a new third equation. Our new third equation is equals to z is equals to 3. So we've successfully gone downwards, eliminating x, eliminating y. Now we have to now go upwards. We now have to go upwards, going up. Now we have to go up, eliminating z here and eliminating y and z in this equation. Okay, therefore, if you want to eliminate z in this equation, you have to add the second equation to the third equation, but the third equation has to be a 7z. So in the third equation, you multiply by 7. So you are going to say 2y minus 7z is equals to minus 17, which is our second equation. We're going to add it to 7 times z is equals to 7z is equals to 7 times 3, 21. Therefore, our new second equation will be 2y 7z. You're adding first second equation to third equation. 2y minus 7z plus 7z is equals to 0z. It's equals to 17 minus 17 plus 21, which is equals to 4. Therefore, if you divide both sides by 2, y is equals to 2. Remember, I've just divided both sides by 2, so that I'm left with only y, the variable y. So my new equation 2 is equals to y is equals to 2. So now I have to rewrite my entire equation, and I say my first equation was this equation, but Now my first equation is x plus y plus 2z is equals to 9. This is still my first equation. But now, however, my second equation has now changed. It's now only y is equals to 2. My third equation is still z is equals to 3. So this is now my second equation and my third equation. Now I move up. I want to eliminate y in this equation. So I add my first equation to my second equation. But however, I have to multiply my second equation with minus 1. So I say my first equation, x plus y plus 2z is equals to 9. Now I'm adding it to equation 2, which I have multiplied by minus 1, so that I can eliminate y. So I say minus 1 times y is equals to minus y is equals to minus 1 times 2 is equals to minus 2. Therefore, the answer is my first equation, and I'm going to get a new equation 1. So I'll get x plus 0y plus 2z is equals to 9 minus 2 is equals to 7. So my new equation 1 is indicated here. So I have to, if I rewrite the whole entire equation, I will have x plus 2z is equals to 7. That's my new equation. Then I have my y is equals to 2 is my second equation. Z is equals to 3 is my third equation. So I've successfully eliminated y in the first equation. Now I have to eliminate z in the first equation. Now, in order for me to eliminate z in the first equation, I have to add the first equation to the third equation so that I get a new equation 1. But however, I have 2z in my first equation and I have z in my third equation, so I have to have a minus 2z here. So I multiply those entire equation by minus 2. So I'll say x plus 2z is equals to 7. Add 2 minus 2 times z equals to minus 2z minus 2 times 3 minus 6. So I'm adding it to this equation to get a new equation 1. Therefore, x plus x, I'll get x here, x plus 0 is x, 2z minus 2z is equals to 0z. Then 7 minus 6 is equals to 1. So x is equals to 1. So this is my new equation 1. Therefore, if I rewrite now the entire system linear equations, I will have x is equals to 1. Then I will have y is equals to 2. Z is equals to 3. Therefore, I have